The law of sines. This is one of those where the little formula for it is really pretty easy to remember. Okay? And the concept for it is actually does make a lot of sense. It's that the sine of angle A over the length of the opposing side, so these two match up, that makes a ratio that's the same exact ratio for the other ones too. So the sizes might be different. Okay? If I call this angle A, and this is side A, angle A and side A are a lot bigger than angle B and side B. But the relationship of the sine to this length is the same as the sine of this to that length. Smaller, clearly it's smaller, but the relationship's the same. So if this were to come out to say 0.21, this would come out to 0.21, and so would this. This would be 0.21. Same exact ratio. That allows us to solve lots of problems for triangles. Okay? And we're going to do that where in all the triangles generally, let's do one like this. So I'll call A, B, C, A, C, and B. So lowercase c here. As long as you're given three things, you can solve for the other three. Solving a triangle means all of the angles and all of the sides. So we're trying to get 6 things, and you are, as long as you're given any 3, you can get the other 3. But for the law of sines, you have to have at least 2 of them matching. You have to have an angle on one side across from it, and any 2 other things. If you aren't given that, that's what section 6.2 is for. That's what we use the law of cosine. When you don't have a matching pair, the law of cosines gives you what you need. So between the 2 of them, you can solve, as long as you get 3 things, you can solve any triangle that's not 90 degrees. Earlier in chapter 5, everything we did were all right triangles. Well, when you don't have a right triangle, you can work with this. The bottom of this first page comes from a prior textbook. The one you have has some similar stuff like this too, but I always like this one. So we're going to use this to talk about the, whoops, that was not what I wanted to do. How do I get it out of there? Okay. Okay. Get out of here. Source. No, that's not that much. Excuse me for a minute. Let me get out of it. Good. Now there's the right key. Okay. And we're still learning this. This is new this year. So, I want to do zoom. You have sometimes where you can have 2 triangles or 1 triangle. So, look at this. It's possible to be given an angle and an amount of a side that, based on the other one, it's not possible to make an angle. And that's because this is too small. If you have it a certain size, you have a right triangle. If it's too large, it's not really too large. If A here is really big, that means you can actually have a smaller side triangle or a larger triangle as long as A is a certain size. Now, if you think about it, that makes some sense. You know, this side length here, too small, too large is fine because you get double triangles out of it, or exactly the same, the exact right length that you need so you can make a right triangle. All this depends upon this B sine A. Now, you've used that before because I know this was touched. We touched this in integrated 3, or if you were at another school, it was touched at 2. That's the key to the whole thing, because that's the length that you need, the exact length you need to make a right triangle would be B sine A. So if A is too small, if A is smaller than that, then you can't use it. If A is bigger than that, then that means you have 2 triangles. And that's the key that we're going to focus on right now. Because we're going to do a couple of problems showing you that you have that you have 2 triangles on it. And you can have it where it's way too large that it would come past here, then you only have 1 solution. So the way this paper is set up, these 4 possibilities are when A is an acute angle. If A is obtuse, you really only have 2 choices, 1 solution or no solution. Okay, so you can tell that just by if A is less than or equal to B or right here. If A was equal to B, you'd have it right on top here and you wouldn't have a triangle. There'd be no extra space in there, so it's not possible. Okay, let's take a look on the next page here. And what we're going to do,
Should we have to memorize the law of sines and the philosophy of triangles?
Good question. Yes, you have to memorize that. Now, in a way, you have to memorize that, but on the test, I will give you this much. I will give you a little box like this that gives you each of these things. And it'll be just like this. So if you can remember which ones are which and what they mean, then basically you can figure it out. So I'm not going to make you memorize that except to recognize which ones are which. And notice in this little thing that these two are italicized. Well, when you look back at this paper that I gave you, those two are these, the ones that are for when A is a right or obtuse angle. I wish it was easier to move this up and down. So 4 of these are for an acute angle, 2 of them are for a right angle. 2 of these are italicized, those are the ones for the obtuse angle, and the other 4 are the main ones that we're looking at. So what we're going to do is solve for this triangle, and what that means is to get all, reduce this a bit so I can get all that in there. We're going to use the law of sines to solve this triangle, or triangles, and we know one side, and we know the opposing amount of the length of the opposing side. That means we can use the law of sines, and we know one other thing. So what's missing is we need angle B, angle C, and side C. If there's a second triangle, we need those also again. And what I'm going to show you with this one is that if you do know the first triangle, and you know there's a second one, I'm going to focus here on this one on how you figure out what the second triangle is, how to move to it. Okay, so first thing is we need to determine if it really does have 2 triangles. And that's where you need to figure out what B times sine A is. Okay, that's what the key to this thing was. B sine A will be that length here. And then what we'll do is we'll see is A less than it, or is A greater than it, and B greater than it also. Than A, then we'll have 2 solutions, okay? And if it's equal to A, it'll be 1 solution. So we know that B is 8 and A is 24. So 8 times the sine of 34 gives me 4.4735, so 4.47, good enough, is approximately 4.47. So I see that this is smaller than A, which is smaller than B, and that tells me, let's see, that was this one right here, and that's the one on the front page that tells you it's 2 triangles. So yes, we have 2 triangles. Okay, so yes, 2 triangles. So we now know that. Okay, so I have sort of a methodical way that I do these out, so I'm going to walk you through them. You can do them any way you want to get them right, but I'm going to show you sort of the steps that I do it. I'm not going to worry about this until I get the answers. So what I'm going to do now is think first triangle. I need to know what A is and A, B and B, C and C. Equals, 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 and equals. I already know that A is 34 degrees, that A is 6 millimeters, and that B is 8 millimeters. So I have 3 things to find out. I also am going to need to know the second triangle, and these 3 will be the same things. I need to know A and A, B and B, C and C. And these 3 given things are exactly the same. Now, this may seem redundant because you already got these at the beginning and you already have a place here to put the answer ones, but to me, it helps mentally to see this and recognize that I've got to fill in these blanks and I have these things. Okay. I'm going to use the space down here to figure things out. And the first thing is knowing sine A over A is equal to sine B over B. I have 3 of the 4 things here. I have A, 34 degrees, I have 6 millimeters, I have 8 millimeters. So there are 4 things in this part. As long as I have 3 of them, I can solve for the other one. So let's do that. Sine 34 degrees over 6 is equal to sine B over 8. Cross multiply. and divide. So we're going to have that sine B is equal to 8 sine 34. That's actually 6 times sine B, but we can just divide by it here now. Okay, so 6 times sine B, and then I divide by 6. So I get 8 times sine of 34 divided by 6. That actually means it's sine minus 1 of 8 sine 34 over 6. So this is a case where this is a mess of stuff to do, but the angle B will be equal to sine minus 1 of that mess. So I'll just put it in the calculator. I'll do sine minus 1 key of 8 times sine 34 divided by 6. And that's going to be equal to angle B. Well, when I put it in the calculator, that tells me that B is approximately 48 degrees. I come up to 48 degrees. Okay? So I'll go through and show it here. And it needs to see it. So I'm going to do second function sine minus 1. 8, oops, I want to put parentheses. 8 times the sine of 34, close parentheses, divide that by 6, close the parentheses. So check that. I have 8 sine 34, and divide that by 6, and sine minus 1 of all that. I get 48.2098. So I can call it 48.2. Yes, I will. I'll call it 48.2 degrees. So right up here now, I now know that it's 48.2 degrees. The next part of this is really easy, because I now have 2 angles out of 3 on a triangle. Every triangle, all 3 angles add up to 180. So 180 minus 34 minus 48, 180 minus 34 minus 48.2 would be 97.8, I believe. 180 minus 34 minus 48.2, 97.8. And that's the other triangle. This is A, this is B, the other angle is C. So that means C is equal to that, 97.8. The only thing left on this triangle is that C. So let's figure that out. I now know the angle C. I don't know the side C, but I know these two and I know these two. So I can do this. I can just do it with C. So I'm going to do sine A over A equals sine C over C. Sine of 34 over 6 equals the sine of 97.8 over C. So plug things in, cross multiply. So C times that is equal to 6 times this. 6 times sine 97.8. So C times that means I can divide by sine 34. This one's not a minus 1 key, it's just a calculate the number, it's the length of the side. So 6 times the sine of 97.8, as that, and divide by sine of 34, and they get 3.32. These things off because I think the number is different.
You did times sine 34.
Okay. Now, one of the ways I know, good, I'm going to fix that, is notice that this angle, 34 degrees, is 6 millimeters. The next angle is larger than 34, so the side length should be larger too. This angle is larger than both of them, so this side length needs to be larger. So when I see a number that's smaller, something's wrong. And that's where it said it was multiplying, it was dividing. I multiplied when I should have divided. Thank you. But you see how I caught that by realizing the number's not reasonable. Because if that's the largest angle, it should have the largest side length as the matching one. Okay, then the little things that you learned in Integrated 2 and earlier than that in middle school actually comes into play, things like that you remember about triangles. So now let's do it right. 6 times the sine of 97.8 equals that, and now I'm dividing by sine of 34. 10.63, that's more reasonable. This one's larger, so the side length larger. This one's larger, so the side length should be larger. 10.6, reasonable to say 10.6. And it's all in millimeters. So over here, I can plug those in now. 48.2 degrees, 97.8 degrees, and 10.6 millimeters. Okay, we need to move over to the second triangle. The way that you do that is remember that you're dealing with a supplemental angle. I need this picture back. You have this two triangles set up like this. What we just did here is we figured out one of these, like this one here. I figured out what B was here. That B and this B are exactly the same because this is length A. Can't see it because the zoom doesn't work so well on it. Let's come down and see. That's supposed to be a little A here, side length A and side length A. Since you have side length A and A, you have an isosceles triangle. If it's an isosceles triangle, then these two angles are the same, so this one is also B. That means you can figure out what this angle is, because together they add up to 180. Since this is a straight line here, and we know that this B here, in this case, is what, 48.2? We know this is 48.2 degrees, so we know this one's 48.2 degrees. These two together add up to 180, so 180 minus 48.2 will give us this other B. I'll call it B prime right now for the second one. So let's come back over here. So because of them being supplemental angles and adding up to 180, I can come here and I can do 180 take away 48.2, and that will give me angle B. The other angle B, the obtuse angle B. So 180 minus 48.2, that's like 180 minus 50, which is 130, and 2.2, 132.2, no, 150, well, 130, 130 point, okay, let's play with it. I think it's 131.8. 180 minus the 48.2, 131.8, that is going to be our B, 131.8 degrees. Of all of this, this is probably the key thing that you need to keep in mind in order to move from one triangle to the other. All the rest of this is just using the somewhat simple law of sines, adding up to 180 for the triangle, not hard to do. This is the key thing that you don't want to forget. If you remember that, you can move over to this triangle, because now it's easy. 34 and 131, we need to add up to 180, so let's do, for C here, let's do 180 minus 34 minus 131, 131.8. So 180 minus 34 minus 131.8. Ooh, 14.2. Okay, so that comes to C is equal to 14.2 degrees. 14.2 degrees. And to find side C, it's just like we did here now. On this other triangle, once I knew sine A and sine C, or knew the angles A and C, I could solve for C, so I'm going to do the same thing here. So I'm going to do sine A, sine of 34 over A over 6, what you do, is equal to the sine of 14.2 over C. So C is equal to, or C times that, is equal to sine 14.2 times 6, and divide by the sine of 34 degrees. Okay, let's see if I calculate this one right this time. 6 times sine of 14.2, and I get that from multiplying. Now divide by sine of 34, 2.63. So that's saying it's about 2.6 millimeters. Now, is that a reasonable answer? Well, 34 is 6, 131.8 should be a larger length. as long as the smallest one is going to be a much smaller length. So this would work because of the way the angles, that's a much longer angle. Because this is a much smaller C, you could still have the 8 ring. So at the bare minimum is that the smallest angle should have the smallest side opposite. And so that seems to be okay with it. Okay? 131.8 degrees, 14.2 degrees, and 2.6 millimeters. So let's quickly review the steps that I did here. And we'll look at another one here. So the first thing I did was to verify how many triangles it is. In this case, 2. If it had only been 1, we wouldn't have had to do half of the stuff, or about a third of the stuff, actually. If it had only been 1, you wouldn't have had to worry about it. And you would have known that from using the information here and remembering what the first page says. And the second thing that I did is I set this up so that I could use it to put in the numbers and help me knowing which one I'm getting to. The third thing I did was that I found angle B by using the law of sines. Fourth thing I did is I used the basic angles of triangle add up to 180 in order to find angle C. And then the fifth thing I did was I used that angle and the other information. So I did the law of sines again in order to find that what C was equal to. Find it right down there. It's where the clock is. To find that. Then this became the 6th step. Once I did that and found those, the 6th step was to figure out how to move to the other side. And that's the key thing to remember. It's that both B angles are going to add up to 180. And then I solved for C, 7th step. And the 8th step was the law of sines again. Yeah, 8 simple steps. Each one of them, actually, if you think about it, is not hard to do. It's more a matter of recognizing what to do, especially to recognize that one there. Okay. My next papers. How many papers here? There's a practice one to do there, but I'll leave that one for now. I want to move to page 4. This page 3 one is the exact same kind of thing, but I'll leave that for now because I think if there's time you can do that. You can do it here later, but you can do it at home too. But let's take a look at the 4th one, area of a triangle. Now, if you've done this section and the next one already, you've noticed that both the law of sines and law of cosines, both those sections have a method of determining an area of a triangle. 2 different methods. Interesting ones. I've always sort of wondered why they put them in. I think they don't really have a better place in the trigonometric sections to put them in, so they put them in here. The method sort of matches the formula, but these are ones that you all have to actually just plain memorize the formula, but they're not really hard formulas, so I don't think this one will be that taxing. So let's look at this area triangle. So in this one, notice that we have a side length and another side length, and we have an angle. So it's sort of set up like this. I want to make not too big there. So I'm going to call that angle C at 40 degrees. And then there's a length across from it, but we don't know that. What we know instead is we know this length, we call that B at 14. And A is 10. So what we really have is we have an angle and we have the 2 side lengths that together make up that angle. Angle C has side length A and side length B on the sides of it. But we don't know the other angles and we don't know the side length across from C. This is all the information you need in order to find the area. Okay? So the formula for that is that the area of the triangle is equal to 1/2. Remember, 1/2 length times width. The 1/2 is still here. But it's 1/2 times the 2 of these, A and B, times A, times B, times the sine of 40 degrees. Now, if you think about it, that's not that hard of a formula to remember. If you have 2 sides and the angle that's between them, you multiply those 2 sides times the sine of that angle and take half of it and you have the area. by the way, before I go on, this is true for any two sides, because let's say that instead of having sine of c, so I guess I should have put c in there. If I had, say it was b here, and it was c and it was a, so what? It would still be the same thing. It would be a times c sine of b. Or, if I had the third combination, where I know angle A, then it would be b times c times the sine of a. Notice it's the same pattern. If you have an angle, you have the other two sides. This angle, the other two sides. This angle, the other two sides. Remembering that, and the formula is pretty easy. So that's what I want you to do. I want you to think about the pattern of this. So if I had given you C and B and angle A, you'd be looking at this one, but it would still be the same idea. Now let's actually do it. The area is 1/2, and we're using this one, times 10 times 14 times the sine of 40 degrees. 1/2 of 10 is 5, so we have 50, 60, 70. 70 times the sine of 40. Is my number right there? Yep, I think so. Okay. 70 sine of 40. I can do a lot of math in my head, but I can't do a sine and cosine in my head unless it's on an even circle. So sine of 40, 0.6 whatever, times the 70. And it gives me 44.9, or so close to 45. So the area is equal to 45. You just have to watch units. This said units, so that's units, but it's units squared. So the area is 45 units squared. Really easy calculations. It's more a matter of just remembering the pattern for it, and then anytime you're given one of these, which I'll give you one of these, so you can make sure that you know how to, so make sure you can do it.